Hi, this is Josh Keebler. I am going to demonstrate my IPT project for EE320. I had some circuit boards made, so we'll test those here. I had them made from JLC PCB. I panelized it, as they call it. I made both the transmitter and receiver as one board, and I added some plated through holes there along the dashed or the solid line, so that I could score it and separate the two halves. I wish that I had made the through holes a bigger diameter. It would have made it easier to separate. I added, I guess, a footprint for the buck boost module. Of course, there wasn't one by default in KiCad. One thing that I would like to improve is the plated through holes for that buck boost module. The diameter is really small. I was able to just take an old resistor lead and connect them that way, and it worked out well. You can see, maybe not so good on camera, but you can actually see a solder bridge, so it did bridge through. For those, I had just grabbed the default footprint for a plated through hole. I should have used, you can see any of the other components have much bigger diameter through holes, but enough of that. So that's one thing I would change for Rev B. Another would be on the receiver board. I used a footprint for a normal 2.54 millimeter header. And of course, I don't know why I didn't do that on the transmitter side. I did label them. It is that smaller diameter pin pitch. So I would change that as well, because I did have to do some kind of ugly hack job soldering, and that would have been taken care of if I had thought of that. So I would change that. I also didn't put my name or the class project or anything on this board, which I certainly could have. I did component designators. I didn't do the values. That would have also helped. But anyhow, that is the circuit board. It was $2 with a coupon. The shipping was 20 bucks, so I could have had that a lot cheaper if I wanted to wait, but I didn't, so I was able to receive it. You can see here the two halves of the circuit. The oscilloscope probe is a little misleading, but that's just measuring the clock out. I did leave a through hole for the clock out, which you'll see right there. Also one of the smaller diameter. And then I added some spare pads, just because on previous projects it's been nice to have, because on a rev there's always multiple revisions, and it helps if you go to create a bodge or need to jump or something. So I left those there, and of course I was able to use clock out and the ground signal to connect my oscilloscope probes. Of course, I didn't leave room for a header, so again I had to use resistor leads and make kind of a hoop that I could hook onto, but it worked. You'll see here the frequency that I found. The optimal performance or efficiency of the coils is 157 kilohertz. That seemed to give the best performance. I think I was able to get greater distance between the two hoops with the breadboarded circuit, which I've got here. The inductor on the receiver side, I had to use a bigger one. I didn't have the same value as before, but I don't think that should have changed it too much. But anyways, I added a potentiometer, that blue one there, so that I could tune the frequency, and I was able to find where it was brightest. I kept it at a distance and I was able to tune it. So you'll see here the two halves as they get closer. It gets really bright. I used a blue LED because it's got a greater forward voltage drop, so it'll drop out quicker, and then the red will stay lit for a little longer. Oh, another thing I guess is I used different LEDs also on the two circuits. I used some fancy flat top LEDs because I have way more components than I should have. So I figured why not use those, so that could also be coming into play here. I thought about using like an integrated bridge rectifier circuit, because I do have those. They're 4-pin, but I must have spaced on that when I was designing, because I do have those and I thought about them at some point, but I have way more diodes than I do those bridge rectifiers, so I guess it was better for something like this, a class project, to use that. But anyways, there's my circuit. Woo! Oh, that was another thing too that I should mention. I did solder a switch because I didn't like just having the 9-volt battery always plugged in. And that's the other thing that I would take care of on the next rev. I would have added a switch on the board because I had plenty of room. It was really small. And you can see the green light there. So if I turn it off, there we go. No more LEDs. No more signal on the scope. So yeah, I would have liked to have added a footprint for the switch on the board as well. And I'm not sure if people are aware of this, but you can take a dead 9-volt battery, which of course that's all I seem to ever have when I need a good 9-volt battery. But you can actually, if you peel apart a 9-volt battery, you can pry that piece off and make a socket out of it, which is kind of handy. And you've always got dead ones laying around. Alright, well, thanks for watching. Hope this was informative and a good demonstration. Thank you.